So for any real numbers a and b and an integer greater than n, we have the following condition. N to the a times b can be broken up as n to the a times n to the b. Again, a reviewing concept we previously talked about. We also discussed that if n is even, then a and b cannot be negative. If n is even, a and b cannot be negative. If n is odd, then it can be positive or negative. And we saw that with one of our homework problems last night. The n value was cubic. The number inside was negative 162. We could simplify that because the n was odd. This is called the multiplication property of radicals. You can also call it the product property of radicals because product and multiplication mean the same. So for example, if you have two things being multiplied together, you can change those two separate multiplications to a single multiplication. In doing so, you get a perfect square, and you simplify to 4. The same holds true for a cubic. We can also do the converse of that, which means we can take a big number and break it into smaller numbers. So the square root of 32, x to the 8, can be thought of or rewritten as 16 and 2. Because 16 is a perfect square, that allows us to take the square root of 16 as the number 2 and separate them to get a perfect square with a non-perfect square. We also have to take into account the variable. 8 is even, so it divides nicely. 8 divided by 2, because the square root has the imaginary 2 right here, is 4. So we get 4, x to the 4th, is 8 divided by 2 is 4. Square roots of 2. So again, just reviewing kind of what we talked about last week with simplifying radicals. What we're going to do is continue or extend that today. So square root of 16, a to the 24, b to the 13. So again, 16 is a perfect square. It becomes 4. A to the 24, well, 24 is even. That makes that also a perfect square. So we divide 24 by 2 to get 12. B, however, is not a perfect square because it is raised to an odd exponent. So we would think of b to the 13 like b12 and b. So again, it's where that multiplying property comes into play. 12 is then less than 13. It is now even. So you get 4a12 b6 root b. Just the 12 divided by 2, it comes out in front. The 1 less stays behind. sometimes we're going to have radicals multiplied by radicals. So that's where this property comes into play again. So what we do is if there is a number out in front, that follows our normal rule. A number times a number just multiplies those numbers together. So 5 times 3 gives me a 15 out in front. And then what I want to do is I want to combine this cube root with this cube root. So I'm going to take two separate cube roots and make them one. So you're going to multiply 12 by 18. A times A squared. So when you have multiple things being multiplied, you add the exponents. So 1 plus 2 is 3. And then b to the 4th times b squared. So you get b6. Now what's really nice is upon multiplying them, they all became perfect cubes. 216 as a cube is 6. It is the cube root of 6. So you get 15 times negative 6. And then you take your powers of your exponents and divide them. 3 divided by 3 is 1. 6 divided by 3 is 2. John, Stephen, either go to the nurse or lift up your heads. It's super rude. Multiply your numbers together, and your exponents are simplified so they stay. Again, this became a perfect cube, so the cube roots are gone. So 15 times negative 6 becomes negative 60 and 30, 90, A, B squared. We can do the same thing with a 4th root. So again, numbers out in front multiply. And then you want to multiply the numbers inside as well. Three times 2 is 6. And then you get the 4th root. 8 times 2 is 16. X cubed, x to the 5th becomes x8. y2 becomes y4. Going over to your chart, 16 is 2 times 2 times 2 times 2. So the 4th root of 16 is 2. 8 divided by 4 is 2. 4 divided by 4 is 1. So you get 12x2y. So not a whole lot of new, just a little bit of an expansion of what we did on Thursday and Friday. The second property, so we have Multiplication, its opposite property is division. So you can take one big fraction and make it two smaller. Similarly, you can take two smaller and make them one big. So if you have 27 divided by the square root of 3, what we can do is think of that really as like 27 divided by 3 is 1 whole square root. We know 27 divided by 3 is 9. So if the square root of 9 is equal to 3. We can do that with numbers and variables as well. So if you have the cube root of x6 over 8, that one is more helpful to think of the cube root as x to the 6th over the cube root of 8, because then both of those are perfect cubes. 6 divided by 3 is 2. Cube root of 8 is 2. So that's a case where breaking it apart into separate is more helpful. So again, square root of 9 over square root of 4. They're both perfect squares. So you think of them as two separate numbers. And you get 3 halves. So all we're trying to do is take something complicated and make it more simple. I know what 3 halves looks like as a number. I don't know the square root of 9 over 4 until I simplify it to 3 halves. So again, break it into x over 12 over 4, and you get x6 over 2. You'll see that I write out that extra step sometimes so that I don't give up my square roots. There is a rule in math that you cannot have a square root in your denominator. There's a rule in math that you cannot have a square root in the denominator. So we have to do what we call rationalizing or multiplying by what's in the denominator. So here I have the square root of 5. So to get rid of the square root of 5 in the denominator, I'm going to multiply top and bottom by square root 5. My new answer becomes 3 square roots of 5 over 5. When you multiply the exact same square roots times themselves, so if you have 2 square roots times themselves, they become the number underneath. If you have the same square root times itself, it becomes the number underneath. This one is a case where you would want to make one fraction before you try to rationalize. So the rule for dividing variables is top minus bottom. So this is like x to the 6 minus x to the 7, or 6 minus 7. So all the 6's on top cancel. and we get 1 over x. That leads us to a problem similar to the first example, where we cannot have a square root in our denominator. So you have 1 over the square root of x. Yep. Oh, because we're wise. Thank you. Sorry to ask you. Change your problem to an x. Make it an x. There's a y on your page. There should be L on that page. But we're going to treat it like an x because we're already committed to x. Then would not be able to divide. So you have root x on bottom. So you're going to multiply by itself again. That puts a single x in your denominator. And the square root x up top. Square roots need 2. Cube roots need 3. Square roots need 2. So 1, 2. 1, 2. Cube roots need 3. So we have to multiply this problem by 5x because I need 3 of the same cube root to simplify or rationalize the denominator. So that makes this over 5x, because I had 3 5s and 3 x's. And then you're just going to multiply all the numbers together up top. So 6 times 5 times 5, well 25, 5 times 5 is 25, 25 times 6 is 150. And then x times x is x squared. No, like once you have a number on the outside, that number always stays the same. So like this one will always be a 5. Yep. So now if I need 5 of something, you have to multiply by 4y 4 times. The bottom will always become whatever's inside. So this is going to become 4y. 4 times 4 times 4 is 56. The bad news is you have to make sure 768 doesn't divide by one of our fifth root numbers. In this case, it does. Divides by 32. Because 2 to the 5th is 32. So 768 divided by 32 means you could take a 2 out, and that leaves you with 24y. If you want to get fancy, you can make the 2 and 4 half. No, I won't do that though. But if you see that, okay. Otherwise, you're good to leave it. We're not going to do the next page units. X on them. Oh, there isn't one. I already knew you.